compounds. Okay, sharp. Let's say A is B. All right. Let's go. Define the organic molecule. Basically, organic molecules are compounds with the one or more carbon atoms that are covalently linked to one another, or to one another, or with another element. So basically, the organic molecule, organic compound, it must be basically carbon atoms. If it's more than one, it must be linked to one another. That's why we call them that carbon atom can have that ability of catenation, like joining one atom of carbon with another and then forms a long chain. It's one of the good properties of carbons, of carbon, yes. So basically that's an organic molecule. Write down the IUPAC name of compound E. So if you look at compound E, what are you going to say here? Let's find out the longest chain. Compound E. 1, 1, 2, 3, 4. No, 1, 2, 3, 4. Because here I have the double bond. But when I was going through this structure, as you see it there, something was not right. I don't know whether they did it on purpose, but it can't be, because this is a mistake. I don't know how it did happen. Maybe through printing. This molecule does not exist. See this? It's supposed to have 3, but they didn't put a 3 there. I don't know how they will mark it, but it had to be with a 3 so that it is a methyl. Yes, but let's just assume that we put a 3 there so that we have a correct naming as methyl. All right, so it's gonna be 1, 2, 3, 4. So it's gonna be bute. It's gonna be bute, but because it's a double bond, so it's gonna be bute. So it's 1, or it's on carbon atom number 1. Bute 1. You see, it's on carbon atom number 1. So it's gonna be bute 1 in. Bute 1 in. Now I have this side group and I have this side group. So you have the first side group is on carbon atom number 2. So it's gonna be 2, comma. The second side group is 1, 2, 3, 3. Then dash di. What is it? These are methyls. Dimethyl butene 1 in. 2, 3 dimethyl butene 1 in. So basically, how many marks are there? They'll give you a mark there, and they'll also give you a mark there. At least you get those 2 marks. Yes. Then we go to the next question, which is what is H? IUPAC name of H. Where is H? H is here. This is a carboxylic acid. It is a carboxylic acid. So, oh, this no, they are not looking for this. They're looking for H. So this is a ketone. So 1, 2, 3, 4. So it's gonna be butane. Remember, I told you that when it's not alkyl, if it's not alkene. So here you have to write up to there. Butane. This is a ketone which ends with on. So it's gonna be butane 1, 2, 2 on. So butane 2 on. So basically that is it. So that you get 2 marks for the chain and then the position there. Then we go to write down the structure formula of compound B. When they say the structure formula of compound B, let me just clear it up so that we see exactly what are they saying. The structure formula of compound B. What is compound B? Okay, it's here. What is it? It looks to be an ester. So it's gonna be CH3. You put hydrogens. The hydrogens are supposed to be there. Might not put them here. And then this one, because there's no shortage of hydrogen here, So automatically this becomes a chain. CH, that's 1, CH, that's 2, CH, that's 3. Now I put C, 1, 2, 3, O there, and then O, and then hydrogen. So you put the hydrogens. No man. Yes, you put the hydrogens. Yeah, it doesn't end with it's an ester. So it's C. You put the hydrogens completely. Yeah, so that's what the structure formula, but they are talking about in here for compound B. Then we go to structure formula for compound C. Now it is compound C. So here they want the structure formula for compound C. Okay, let's write it. Xn. Xn is 1, 2, 3, 4, 5, 6. It's Xn. Difluoro is 3, 3. 3, 3 difluoro. Let me just count from here. 1, 1, 2, 3. So I have a fluoride here, and I have a fluoride here. Okay. And then then you have 4 methyl, meaning that if I come from this side, 1, 2, 3, 4. So I have a methyl here. Is it methyl? It's ethyl. So I put hydrogens. So you're supposed to have now the hydrogens, you fill it with the hydrogens. So that's the structure which you were supposed to draw when it came to that. Then I don't understand what you are saying. Aneliswa. Don't understand, but I think we are getting there. Hope you are hearing me properly. Yes. If you're not hearing me properly, let me know in the comment section. Yeah. All right. Let's go to the next question, and then we see how did we perform this paper. Yeah, you guys, I salute you. At this time, you are awake. Okay. All right. Let's go to question 2 point. Yes, H, we are done with it. Write down the structure formula of B. Did I write? Yes, I'm done with this. I'm done with this. I'm done with that. The general formula of homologous series to which compound E belong? Where is compound E? Compound E is an alkene. Remember when I was reminding you how to write this? I said that alkene is CH2N. We don't add anything because alkane we add 2 and alkyne we subtract 2. Yes. Structure formula for functional group of F. So we go to functional group of F. F, it is a keton. Therefore, here you just come and write the structure formula of so that's basically what you're supposed to write like that. However, sometimes some people they put a bracket like that, so it's the same thing. It's cool, yes. And then sometimes people add alkyl group that side and alkyl group that side. Still, it's cool. You'll get a mark in that regard. So in that case, the structure formula, we say that it looks like that. Whatever you write it is cool. Then IPAC name of alcohol needed to produce compound B. Where is compound B? Compound B is, we say that compound B is an ester. Since compound B is an ester, let's see which alcohol is used to do what? To remove or to form this ester. Remember I told you guys that the alcohol comes from the carbon atom without without the hydrogen. No, that's the carboxylic acid. So you see this carbon atom, then it means that this part came from the carboxylic acid because this carbon atom didn't have a hydrogen. And then this is where the alcohol is coming from. Since it's one carbon atom, therefore it's going to be CH3 or H. Did I say structure formula? If they say the structure formula, IPAC name of alcohol, they just want the IPAC name. Therefore, if the IPAC name, then I'm just going to say methanol. That's it. Because methanol doesn't have the name, the position, because it's just one carbon atom, and ethane doesn't have the position because it's two carbon atoms. Yes. They are saying that write down letters of the compound that is functional isomer of compound G. Functional isomer of compound G. So now we go back to compound G. G is carboxylic acid. They are saying functional isomer. If it comes to functional isomer, then it means that they want an ester. So you have to look for the what? For the ester. But it must have the same number of carbon atoms. So the only ester we have here is this. But we have to find out if they have the same number. 1, 2 times 3. Meaning that 1, 4, yes, 5, 6. So we come here and we count 1, 2, 3, 4, 5, 6. So automatically B and G are functional isomer. What did they say? So the answer here becomes B, because they are looking for the functional isomer of G. A chain isomer for each other. Chain isomer. Let me check here. Functional isomer of G. Functional isomer of G. Yes. Okay. We got it. Then they're saying that chain isomer of each other. Chain isomer. Chain isomer. Okay. This is carboxylic acid. Do you have any other carboxylic acid? This is another carboxylic acid, but this is heptanoic acid. This is hexanoic acid, so it can't work. This one is a carboxylic acid. Let's look. 1, 2, 3, 4, 5, 6. So it has 6 carbons. And even hexanoic acid is also having 6 carbons. Yeah, so definitely D and G. D and G. So D and G, they are chain isomer. Remember that it's supposed to be the same functional group. It's just a different arrangement of atoms on the parent chain. It's the one which changes, so that now, yeah. So we go to the next one, the next question, and then we see. So we have got it. We've got that one. We have got that one. Oh, we finished question 2. Okay, let's go to question 3, and then we find out how did you perform this question 2. They're saying the relationship between the boiling point and the molecular mass of aldehydes, carboxylic acid, aldehydes, carboxylic acids, and primary alcohol is investigated. Okay, the curve PQ, PR, and S are obtained. All compounds used a straight chain. This is a key point, a straight chain. So it means that you won't be disturbed. Define boiling point. This one you know. Temperature at which the vapor pressure of a substance is equal to the atmospheric pressure. And then, yes. So definition you know. In most cases I don't talk about them. Yes. 3.2, because it doesn't change. Write down the conclusion that could be. Okay, could be made for P. So where is P? Without even looking at what is P, but you see that it increases. The boiling point increases as this is increasing. We always start with the y-axis, because the y-axis depends on x-axis. You can't say that the mass increases as boiling point increases. No, it's the boiling point increases as the mass increases. Yes, why? Because the mass causes the boiling point to increase. If you have reversed, maybe they could give you a tick, but that's the most correct answer. Then they're saying that explain the answer and the structure. Okay. In this case, because it is the same molecule, because the same molecule, it means that it will have the same type of intermolecular forces of attraction. But as the mass increase, the London forces increase. So it means that as the mass increase, the London forces for this compound P increase, and then this will require more heat to break these bonds so that it can boil. You understand? So that's how we're supposed to explain, talking about London forces increasing the boiling point because of the high amount of energy which will be required to break those bonds. Then you get it. Yes. Then they're saying that curve R represents alcohol. Curve R, where is curve R? Represents the alcohol. Okay, if this is alcohol, then automatically this is carboxylic acid. And then this is aldehyde. Yes. So if this is alcohol, then this is carboxylic acid. So why am I saying that? I'm just saying because they have said R is alcohol. And then if you look at the intermolecular forces of attraction here on S, on this one has dipole forces and London forces. This one has hydrogen bonds and the London force. This one has London, hydrogen, and then dipole. You see, it means that this will require more heat to be broken down. Therefore, its boiling point is a little bit higher compared to alcohol. And then this one, hydrogen bonds is stronger than dipole. Therefore, the boiling point is higher than that of. Okay, let's go to the question and then we see. Which homologous series is represented by S? So we have said it. So it is an aldehyde. And they are saying that explain your answer. So I've tried to explain that it has London force, and dipole forces which are weaker than the hydrogen bond, yes, and London force which are found in alcohol. Therefore, alcohol will require more heat to break its bond so that it can boil. Hence, its boiling point is higher than that of the aldehyde. So basically, that's what you're supposed to explain. My words could be that too much. Maybe you explained in a different version. Yeah, still it's not a big deal. As long as you have talked about the things which they want you to talk about. Then we go to the next question, which is they're saying that molecular mass of compound with a boiling point 97. Okay, R is graph R, write down the molecular mass. Okay, we have to go back and we'll find out where it's 97. They say 97. Yeah, unfortunately, boiling point 97. The graph can't show nice of R, the boiling point around 97. So if you look at 97, just check here on this paper if I can find 97 is around here. So I have to draw a line touching down. Yes, and basically if you check here, it's gonna be was 50, 70, then automatically this is 60. But if you calculate the boxes, the small boxes, you'll find out that it is 60. So the answer here will become 60 because that's the molecular mass. So the molecular mass is going to be 60. So the IPAC name of compound is, this is 2 marks. 2 marks there. Where do I get those 2 marks from? So basically here, you need to find out which alcohol has 60. That's all. Yes, which alcohol has a 60. So it's easy to calculate. How do you calculate? You can use the formula of C and H2 and yes plus 1. Yes, plus 1. So basically that's the formula you're supposed to use, and then you're able to find. If you substitute, you'll find out that it is CH3, CH2, CH2 OH. Why this? Because why not branched? Why not secondary alkyl? Yes, because it could be here, because here at the beginning they said these are straight chain molecules, so that makes it to be not that way, not to talk about the branched or yes. So they're saying that, so the answer in this case is supposed to be, they say IPAC name, so it's gonna be 1 2 3, it's gonna be propanol. That's what they want. Propanol. Yes, maybe they will give a mark for the that, and also they give a mark for the main chain. So guys, that's how you're supposed to answer that question.